Hello learners, in this video we are going to see intersymbol interference. Before we are going to see intersymbol interference, we first see baseband transmission. What is meant by baseband transmission? Baseband is nothing but a information bearing signal that the spectrum of the information bearing signal is lies between 0 to some finite value. So for the positive frequency, it is called as baseband signal. Okay, here, here consider this is the baseband signal. This the spectrum of the baseband signal. Here this is the spectrum. Okay, this is the consider this is the spectrum. The spectrum of the baseband signal. The spectrum of the baseband signal is lies between 0 to some finite value. This signal is called as baseband signal. The input data stream is being a baseband signal. The data transmission system is called as baseband system. In this baseband transmission, there is no carrier modulation in the transmitter side, so there is no carrier demodulation in the receiver side. Baseband binary data transmission system. This is the baseband binary data transmission system. In this baseband binary data transmission system, the input binary data is given into the pulse amplitude modulator. This pulse amplitude modulator is convert the given binary sequence into the new binary sequence, new sequence. This sequence is given into the transmit filter. The impulse function of transmit filter is denoted as G of t, and then the output of the transmit filter is S of t, that is given into the channel. The channel characteristic is characterized as the impulse responses H of t. In this channel, the white Gaussian noise is added, and the in receiver side, this is the channel side. In receiver side, the received filter is receive the input signal. That input signal is represented as x of t. X of t is nothing but the output of the s of t plus w of t is given into the receiver filter. In this receiver filter, the sample output is taken for every ITB time period, and then the output is given to the decision device. Depending upon the threshold value, the binary value is calculated from the given input. The decision device is decide the value whether the value is 1 or 0. Okay, this is the baseband binary data transmission system. Okay, in baseband binary data transmission system, in this block diagram, you may see pulse amplitude modulator. In this pulse amplitude modulation, it is the most efficient scheme for data transmission, and it utilizes the transmit power and channel bandwidth effectively. The pulse amplitude modulator it changes the input binary data stream into a new sequence. Yeah, if the binary symbol is 1, then the new sequence value is +1. If the binary symbol is 0, the new symbol value is -1. The sequence of the data pulse is produced to the transmit filter. The transmit filter impulse response is denoted as G of t. The output of the transmit filter is S of t is equal to summation AK G of t minus KTB. That is, some weighted is multiplied with the pulse function. Then so the system is called as a linear modulator system. Uh, I already told that the binary data stream is represented by the sequence AK. If AK equal to +1 for symbol 1, AK equal to -1 for symbol 0, then the pulse the new sequence is modulated with the basic pulse G of t, and it superpose the linear to form the transmit signal. Okay, that is this output of the transmit filter is the modulation, linear modulation. And then the signal S of t is naturally modified by the channel noise. In this channel, the impulse response of the channel is represented as h of t, and the received signal is x of t is passed through the receiver filter. The receiver filter impulse response is c of t, and the filter output y of t is sampled synchronously with the transmitter. The sampling instant is determined by the clock pulse or timing interval. The sequence of the sample is obtained to reconstruct the original data by using the decision device. The decision device is find the value of the original binary signal by using the threshold value. Here the symbol 1 and symbol 0 are equally probable, and then the amount of the each sample is compared with the 0 threshold value. If the 0 threshold value is exceed, then the decision is the favor of symbol 1. If the zero the threshold, the decision is does not exceed the zero threshold, then it will be favor to symbol 0. And then if the sample amplitude is equal to the zero threshold, then the receiver is simply make a random guess. The receiver filter output y of t is equal to summation ak p of t minus ktb. Here this p minus ktb is the pulse. It represents the time delay of the system. That is the time delay. The p of t minus ktb is the time delay of the system, and it also represents the transmission delay through the system. And then if the delay is here we make the delay, here we consider the delay is equal to 0 and the channel noise is ignored. Here, the scaled pulse, P of t is the scaled pulse. It is the double conversion of the impulse response of the transmit filter and impulse response of the H of t channel and impulse response of the receive filter. P of t is equal to G of t conversion of H of t conversion of C of t. This is the double conversion. This G of t is the impulse response of transmit filter, H of t is the impulse response of channel, and C of t is the impulse response of the receiver. We know that conversion in time domain is transferred into the multiplication in frequency domain. So P of f equal to G of f into H of s into C of s. Here we P of f, G of f, H of f, C of f are the Fourier transform of P of t, G of t, H of t, C of t respectively. And then the receiver filter output. The receiver filter output y of t is sampled at every ti equal to itb time period, and y of ti is equal to summation k equal to minus infinity to plus infinity ak into p of I minus k tb. Here, if we expand this equation, we will get uh, y of ti is equal to ai plus summation k equal to minus into plus infinity k not equal to I ak p of I minus k into tb. Here the first term is represent the desired binary data, and second term is represent the residual effect of other transmitted bit on the encoding side. The residual effect of the pulse the residual effect of the pulse is occurring after or before the sampling instant is called as intersymbol interference. In the absence of the intersymbol interference and channel noise, we observe that y of ta is equal to aa. Under the ideal condition, ith transmitted bit is decoded correctly. Thank you.